In this problem, we're given the following diagram. We need to find the value RL right here that results in maximum power being transferred to our RL. We also need to calculate the maximum power that can be delivered to RL. So first we're going to find our resistance. We can do this with source transformation. We need to look at the 360 volts and our 30 ohms of resistance. If we look in section 4.9 that's in the notes linked below, we can see this is a perfect setup to transfer this into amps and a resistor in parallel like this with our 150 ohms. To do this, we first need to find the actual current. We're going to say that our current is equal to, using Ohm's law, voltage over resistance. Our voltage here is 360 volts and our resistance here is 30 ohms. So if we do this, we're going to get that I is equal to 12 amps of current. Plugging this into our equation, we're going to rework this and say that our current is flowing this way. It is 12 amps, and then we have our resistor now in parallel right here, which is 30 ohms of resistance with our 150 ohms of resistance right here. We then have our terminal A, our terminal B, and then the resistance of RL to the right of it. Now that our 30 ohm resistor and our 150 ohm resistor are in parallel, we can use the parallel formula, which is 1 divided by the first resistor plus 1 divided by the second resistor. And then this is all being raised to the power of -1. This will give us a 25. So our resistance here is 25 ohms. And we can see that this is going to be equivalent to our RL. So our answer for part A is 25 ohms. We can also see this if we look in the notes. 4.12 for maximum power transfer, again linked below in the description. Next, we have to find our max power. Well, we know the formula for our max power is voltage squared divided by 4 times our R of L. We need to find the voltage. The only way to find the voltage of this is to put it in the Thévenin equation. For this, we need a voltage and then a resistance in series with it. So we can use source transformation once again to convert this. We're going to say that our voltage is equal to our current times our resistance. We know that our current here is 12 amps and our resistance here is 25 amps. So our voltage is going to be 300 volts. Now we can rewrite this. We are going to have our circle plus minus inside of it, 300 volts, and then our resistor in parallel, which is 25 ohms. And then we are going to have our terminals A and terminals B. And then in between here, we are going to have our RL. And this looks exactly like, if we look at the notes, what our maximum power transfer will be. So we're going to plug everything in. We're going to say that our power, and I'll do this in green, is equal to our voltage squared, so 300 squared, V squared, over 4 times resistance, which we know to be 25 ohms. And if we do this, we're going to get that our power is equal to 900 watts. So this is the part B answer. And this is how you do this problem. If you want more problems like this, there's a playlist linked below in the description close to the notes that'll help study for Introduction to Circuit Analysis.